Welcome to video 6 of 7 covering quadratic theory at higher maths. This video is going to focus on the intersection of a line and a quadratic. So, learning intentions. I want you to understand how and be able to determine if and where a straight line intersects a quadratic. So, when a straight line meets a parabola, we'll do one of the following. There are only three options. Hopefully some of you have had a wee think about this and think a straight line can never change direction. So that kind of gives away some of what you're doing. And a parabola is a unique shape, the U shape, and that can never change. So since those two things can never change direction from their kind of generic shape, a straight line can either intersect a parabola at two distinct points, touch only one point, and will be a tangent to that point in the curve. Key thing you got to understand here when I use the word tangent, we've dealt with tangents to circles at National 5. They're not quite the same in that a tangent to a circle means the circle, it will only ever touch the circle and never intersect it. Now, a tangent to a quadratic will never intersect the quadratic again, but when we deal with tangents to further equations like polynomials, the level above quadratic, it can be a tangent and then have another intersection point. So, at quadratics, if it's a tangent, yes, it will never intersect the quadratic, but when we deal with tangents later in the course, which will be the next topic, polynomials, tangent doesn't necessarily mean the line will never intersect again. It just means at that point it touches and shares a common point. And will share the same gradient, but again, that's something we'll cover later. The third option is that it never touches the parabola at all. So no matter what direction the parabola goes in, the straight line will either be below it or above it, depending whether you've got a min or max. So an intersection equation can be created by simultaneous equations. Again, I refer to the statements I made. Simultaneous equations we learned at National 5 is actually a skill we're going to use a lot within higher. So everything you do in maths becomes a skill for doing something else. It tends to be the building block nature of maths. So we're going to use simultaneous equations. It's not limited to straight lines. We introduce you in the form of straight lines because they're both the easiest type of equation to do it. But now that you have quadratics knowledge, now you have further straight line knowledge and further quadratic knowledge covered in the videos that I've done, we can now introduce the fact that simultaneous equations can be used for any type of equation. And in this case, we're going to do the intersection between a straight line equation and a quadratic equation. And as I stated before, it's simultaneous equation by substitution, which will be the more effective method than the elimination method. Definitely the case when we're dealing with straight lines and quadratics. When we create the intersection equation, given that it can only cut at 2, 1, or 0, hopefully you'll understand that the only type of equation that could give two solutions, 1 and none, will be a quadratic. So therefore, the intersection equation itself will be a quadratic if you rearrange into equal 0 form. And if it is rearranged into equal 0 form, we can then apply the discriminant to the intersection equation. Be clear here, it's very difficult now at the stages you're dealing with is that you will start with a quadratic, start with a straight line, you will equate them together and you'll end up with another quadratic. It's key that you apply the discriminant to the intersection equation quadratic, not the original one you were given. So we use it in the same way as determining roots, but this time the answer is a different context. So what we do is the discriminant will tell us whether the intersection equation has roots, but the solution, those roots are actually the solution to the question of, does the straight line intersect the equation? And if the roots come out as in there's none, then the intersection equation is saying that the straight line and quadratic equation don't intersect. If the intersection equation discriminant comes out as equal to 0, it's saying the straight line and quadratic are intersecting at one place only, which therefore makes the straight line a tangent. And if it comes out as having, b squared minus 4ac greater than 0, for the intersection equation, it's telling us that we have 2 points of contact. And it's shown diagrammatically. First diagram, 2 intersection points, you'll get a discriminant for the intersection equation that'll be greater than 0. If there's one intersection point and therefore a tangent, the discriminant for the intersection equation will be equal to 0. And if there is no intersection point, the discriminant for the intersection equation will be less than 0. So it's the key skill to get higher is we're now going to use skills before within. So we're going to start with quadratic, we're going to equate it together, and then we're going to create another quadratic that we then apply the discriminant to. So you get used to this kind of layered approach with the maths, because as it get more complicated, we'll start using more skills at the same time in order to, in order to successfully solve them. You've done this before, because think about the skills that we've taught you with algebra. We taught you simple algebra, then more complicated, then straight line theory, then quadratics. So we've kind of, taken all of this and we build on it, and the same is going to be the case here. So some examples. If you want, feel free to try this example yourself, given I've kind of talked through what you need to do, but I will go over it in a couple of seconds. So it's asking us to show that the line y equals 2x plus 3 intersects the parabola y equals 2x squared minus 5x minus 12 at two distinct places. The word show is a trigger. Again, I re-emphasize, when you are going to do your exam, you need to work on triggers. If the word says show, you're going to have to prove that by the maths you do. And since it only says show that they intersect, we're not being asked to find those points of intersection. We're just being asked to show it does intersect. Now, the trigger is show a line intersects a parabola at two distinct points should be the trigger for I need to use the discriminant, and my discriminant needs to be greater than 0. So we need to form the intersection equation before we can do that. Use substitution and rearrange to equal 0. So we've got one equation being the parabola and one equation being the straight line. At the point of intersection, their y coordinates will be the same. So that's why we can write the algebraic statement y1 equals y2. Subbing in what y1 equals, which is 2x squared minus 5x minus 12, what y2 equals, which is 2x plus 3, we then gain this equation. This is the intersection equation, but it's not in a form where you've gathered like terms. So my next step is to gather the like terms and equate it to 0. It must always be equal to 0 for you to use the discriminant. The rules of quadratics stipulate that it must equal 0 before you can use the discriminant. That still applies even though it's an intersection equation quadratic. The rules of quadratics are the same no matter how we come about. So if you end up with a quadratic in any form of mathematical working, you can then apply the rules of quadratics to that quadratic, no matter what context it's come from. So in this, it must be equal to 0, then we can use the discriminant. So it's as before, a is the coefficient in front of the x squared, b is the coefficient in front of the x term, and c is the coefficient at the end. So subbing them in, again, watch out for negatives and squaring and things like that. Sub the numbers in, do the number work, we get a number of 169, positive 169. And given it's a positive 169, that is our proof. When the discriminant is positive and greater than 0, we have two distinct points. So we can make a statement, since b squared minus 4ac is greater than 0, the line y equals 2x plus 3 intersects y equals 2x squared minus 5x minus 12 at two places. And that's your answer to the question, because all we were asked to do is show, and we've done the maths to show it. Second example, have a go at this. Now, this one's one you've got to pay attention to, because the question starts with, show that the line with equation y equals 3x minus 3 is a tangent to the curve with equation y equals 2x squared minus 5x plus 5. But it also adds the statement at the end, find algebraically the coordinates of the point of contact. Now, this is important, because since we're being asked to find algebraically the point of contact, the process is slightly different, and sometimes that process can actually not involve the discriminant. So most of the time the discriminant is used to show. There are other ways that we can use to show that don't involve the discriminant, but allow us to do more with it. So anyway, before I can do anything, I've got to create my intersection equation. So again, y1, y2, equate them, equate the actual, the x to the right hand sides together, and simplify to make it equal to 0. At this point, since you need to know and find the one point of contact, you factorise instead of using the discriminant, as it will help us achieve both goals. So at this point, always look for the wee tricks that make life easier. You could factorise that using the full factorising method for quadratics, or make life easier by taking a common factor of 2 out. Always look for a common factor, because it will make your life easier for factorising, trust me, on that one. So take the 2 out, you just got a much easier, more straightforward quadratic to factorise. And given we've been asked to show that it's a tangent, if you're factorising a quadratic that has only one root, it will always be equal roots. That's a mathematical fact. So it will always be equal roots. And since we've ended up with equal factors, therefore y equals 3x minus 3 is a tangent. So we can make that statement. Now, we've shown it, but now we need to find algebraically the coordinates point of contact. Well, the points of contact will be the roots to the original quadratic, not to the original, sorry, the roots to the intersection equation of quadratic will be the x-coordinate of the point of intersection between the straight line and quadratic. So that's how, the intersection equation quadratic in context will solve and give us a solution, the x-coordinate solution to the question we asked, which was, when does 3x minus 3 equal 2x squared minus 5x plus 5? So when we solve that root, we get x equals 2. So that is the x-coordinate of the point of contact. We can then sub that into either of our two original equations to find the y-coordinate. Now, at this point, you're free to pick whichever one, but my advice to you would be take the straight line, as that equation is much more straightforward. So sub it in, do the number crunching, and you'll get a y-coordinate 3. Therefore, we can write the statement, therefore point of contact is 2, 3. And since it was a tangent, there is only one point of contact. Example 3. As you know from previous videos, I like to kind of give different examples, kind of test different skills. So feel free to have a go at this one, but pay attention this time. You're not being asked to prove if it cuts, 2, 1, or no places. You're actually being asked to find what value of m will give a tangent to the parabola. So, as I kind of briefly mentioned there, for what values of m is the line with equation y equals mx minus 1 a tangent to the parabola with equation y equals x squared plus 2x plus 3? Key skill, as I've said before, and I'm going to repeat myself quite often, is to understand the words that are screaming out at you, trying to give you an idea of what you should or shouldn't be doing when it comes to a question. In this one, it's for what values of m is the line a tangent. They're telling you, therefore, we're trying to find the values of m that will guarantee that it's a tangent and therefore guarantee that the discriminant of the intersection equation is equal to 0. And that's the key fact that we're going to use here. So we form the intersection equation as before. So a lot of these will always involve an intersection equation, especially when there's mention of two equations and how they interact with each other. So y1, y2, equate them together, rearrange, so bring everything over to the left-hand side. At this point, you realise that the 2x and the minus mx can't go together to form just a single term because of the m. But you do need in standard form, so that means you can't have two separate x terms. So what skill do we have in that scenario? We can factorise. And remember, factorisation, when we first introduce it, usually covers the whole equation. But as you're now using it, you're able to factorise within a bigger question where not all factors of that question are part of the factorising. So here, I can take out x as a common factor out of the 2x and minus mx terms only, which will lead to x squared plus bracket 2 minus m, close bracket x plus 4. And I have one x squared term, one x term, and one coefficient. That is now in standard form, so I can now use the discriminant. So use the discriminant to find the value, so it could be 2, of m that make the line a tangent. So a is 1, b is 2 minus m, so you take the whole coefficient, 1 involves n, and c is 4. We've been told to be a tangent that b squared minus 4ac must equal 0. So that's how we set up an equation. And from setting that equation up, we are going to then be able to solve for m. So for you to be able to solve for an unknown in an equation, you've got to know a fact that allows you to create an equation or an equation depending on the question. So in this question, we've created an inequation. So subbing in the values, we get 2 minus m all squared minus 4 times 1 times 4. Simplify the algebra, i.e. multiply out the square, the double bracket. Simplify the algebra and we get to m squared minus 4m minus 12 equals 0. So what we've got is a third quadratic. We were given a quadratic that was intersecting with a line. We used them together to create an intersection quadratic, which we applied the discriminant to. And we've now created a discriminant, but created a new quadratic that's not to do with x, but is a quadratic to do with m, which means if it's equal to 0 and it's in an equation form, we can solve, and the solutions to that, the values for m, will be the solutions to the question we asked, which was a discriminant equal to 0. So it's really important to understand that sometimes the discriminant itself can become a quadratic that you then have to solve. So you have multiple layers of quadratics. You've just got to get used to that. That's the skills of maths, being able to use multiple layers of the same type of equation, but in obviously all the different contexts. So factorising is our means to solve a quadratic, if it is factorisable, which in these scenarios it will be. Get your two factors, solve for them, and those two values of m will be the solutions to the question you asked, which was what values of m would make the line y equals mx minus 1 a tangent to the parabola y equals x squared plus 2x plus 3. So there's your solutions right there. So therefore, the line will be a tangent to x squared plus 2x plus 3 when m equals 6 and m equals minus 2. So there's two possible values. Example 4, I've just chosen to take one from a past paper just to show you that these type of questions do come up. So it's quite straightforward. Show the line the equation y equals 2x plus 1 does not intersect the parabola with the equation y equals x squared plus 3x plus 4. Now, this one is worth 5 marks. That was back in 2003. I suspect one you have now would be only 3 or 4. The reason being, discriminant was a higher level topic only back in 2003, so they were also testing your discriminant skills. You're now at a stage where discriminant is national 5 skill, so a lot of the work in the marks you would get for subbing in the values, you'll probably only get 1 mark. So the amount of marks available for this type of question at a new hire will be less. So again, create the intersection equation by equating them together. Get the left-hand side, get out all the terms over the left-hand side so that we have an intersection equation in standard form. Since we need to prove they don't intersect, we'll use the discriminant. A equals 1, B equals 1, C equals 3. We're just going to prove a value here because there's no unknown letters. Sub the numbers in and you'll get minus 11. And then make a statement based on the evidence that shows since b squared minus 4ac is less than 0, the line y equals 2x plus 1 does not intersect y equals x squared plus x plus 3. Quite straightforward, and as I said, at your exam level, I suspect a question like that would be 3, at max 4 marks. I don't see it being any more than that, and to be quite honest, I would see it only being 3, but you may get 4.